Hello, in this video we will examine how students can use ClassWiz to support their understanding of bivariate statistics. That is, statistics related to a pair of variables and mostly concerned with the relationships between the variables. Let's start with setting up ClassWiz. We've turned it on, and bivariate data rarely involve frequencies, that is, repeated values. And the example we will use does not involve frequencies, so firstly we will turn off the frequency option in Setup before we start. So Shift and Setup need to go down to the Statistics number 3 and turn the frequencies off with number 2. We'll be using Statistics mode in this video, so choose this mode with Menu and number 6. You can see the Statistics icon there, number 6. A number of statistical models are offered, and all except the first one are for bivariate data. We used the first one in a previous video. We will start with choosing a linear model with number 2. As you can see, ClassWiz now shows a pair of columns for each of the 2 variables. So what are our data? We've got some data here from a lady walking her dog every day. She used her smartphone to record how long her daily walk was in minutes. You can see these various minutes, and how far she walked in kilometres. So let's put these data into ClassWiz. We'll put the time in the X column. So we've got 45, and notice as we tap equals after each one, the data go down the column, 82, 35, 95. If you make a mistake like that, you can use delete, 70, 54, 44, and 83. And the distances are in the Y column. Let's go back to the start. And 4.7, 5.4, and I just noticed I tapped 54 and not 5.4. I'm going to change it to 5.4 so that it's correct. So you should watch what you're doing as you do it, but we can also check later to see if there are any errors. 8.4, 4.5, and an important thing to check is that there are the same number of distances as there are times. So we get to the bottom and the 2 columns should match. That's a good check as well. And indeed they do in this case. So we'll tap C, the all clear column, to begin the analysis. First thing to do is to check that the data seem to have been entered correctly. Good way to do this is to check the 2 variable calculations. Tap the option menu and number 2, and we've got lots of information here. We're just having a quick look at it. The mean time of 60.6 seems about right. It's what you would expect from these kinds of times. Go down a little bit further. N is equal to 10. This is the correct number of observations. We haven't added an extra one or left one off in some way. The mean distance score, the mean y-score, is 5.9. That also seems reasonable given these distances, 3 and 4 kilometres up to 8 kilometres. And we go down a bit further, we can see more information, and finally in the last screen we can see the minimum and the maximum values. Minimum and maximum time values are 35 and 95 minutes, which we can see are the smallest and largest here. And likewise, the minimum and maximum Y values, 3.3 and 8.4, are also there. It's always important to do that kind of a check, but now everything seems okay. You remember we noticed a mistake when we were entering the data, but we corrected it when we did that. So now let's have a closer look at the data. The model we've chosen is a regression model. So let's have a look for number 3, the regression calculations. And we can see the linear model involved here. has a high correlation of about 0.98, suggesting that a line is a good fit to these data. The maximum correlation is 1, so it's very close to 1. It would be a good idea, of course, to plot the data briefly to check visually that they seem to be on a line. And students should do that on a piece of paper. Well, for this purpose, I've used a Casio graphics calculator, and you can see the data plotted here with time along the x-axis and distance along the y-axis. And hand plot, of course, is perfectly okay for this purpose. And it looks like the points lie more or less on a line. We can have a closer look at the regression coefficients by going to the second page of the calculation of the option menu and see regression here, number 4. And here we've got the A and the B values, which are the constant and the slope for the line, and the correlation coefficient, and the x hat and y hat, which allow us to predict values using the regression line. In this case, the slope of the line, let's have a look at the slope, gives us an indication of how many kilometres are covered per minute of walking. We could express this in kilometres per hour by multiplying it by 60. So it looks like the lady walks at a little bit under 5 kilometres per hour, which seems about normal for people walking a dog. We could divide 1 by b, 1 divided by, and we have to go back and get the b, which is on the regression information, and it's number 2. 1 divided by b will tell us about how long it takes her to walk 1 kilometre, a little bit over 12 minutes on average. Predictions should only be undertaken if you're confident that the model is a good one. In this case, it would seem to be a good model, so we might use the data to predict how far she would walk in 1 hour, that is in 60 minutes. So to do that, we're making a prediction. We've got the x value is 60. Now we need to go down again to the regression menu and choose y hat, because we want to predict the y value. What will the y value be when the x value is 60? About how far would we expect her to walk after 60 minutes? And you can see about 5.8 kilometres. Or we could make a prediction of another kind. How long would she take to walk 7 kilometres? So 7, and we again choose option and go down to the regression menu and choose x hat. We want to predict the time it will take to walk 7 kilometres, and that's about 74 minutes. Predictions like these involve interpolation, as they are inside the range of the data. Extrapolation outside the range of the data is always more risky, as they assume that the model continues to hold. In this case, for example, we could predict how far she would walk in 3 hours, which is 180 minutes. And let's do that. How far would be predicting y? And the result of about 15.6 kilometres is predicted by the model, but we'd be a bit more worried about that, as she might get tired, or the dogs might get tired, and it's unlikely that she would keep walking at the same rate for so long. So you need to think about such things. To extrapolate even further to 4 hours of walking, it was probably easier to edit this with the edit command here, change this 18 to 24. So in 4 hours of walking, we predict that she would walk 20.4 kilometres, and that seems very optimistic indeed. So extrapolation is always risky. ClassWiz allows you to add further data or to edit the data. For example, you might delete a suspicious value or an outlier by first tapping the option key, then going down to data. Here we can see here. And suppose we know that the lady did a long walk of 110 minutes, and covered 9.1 kilometres. So let's go down and add that data in. Now, since the data have changed, the regression calculations will now be a little bit different. We can see here the correlation is still very strong, so it's still a linear model, still seems to be a good choice, but these parameters have changed from before. Predictions now will be a little bit different too. For example, let's look at the prediction for 240 minutes. How far would we predict she would walk in that time? Go down to regression, number 4, predict for y, number 5, and the prediction is 19.3 kilometres. It's also possible to investigate an alternative model if it was felt that a linear model may not be appropriate. In this case, as the lady is likely to slow down a bit for longer walks, and a scatter plot seems a little bit curved downwards like this, a logarithmic model may be suitable. And again, students could do this on paper. You can see here there's a curved model, might fit the data a little bit better. So let's look at the same data using a different model. To do that, we need to change the type. Number 1, select the type. Do not enter statistics mode again and choose the type, because then you will lose all of the data. So we've selected the type from option, and we're going to choose instead what would suit these data would be a logarithmic model, because logarithmic curves go down a little bit like that. So let's choose the logarithmic model with number 4. Nothing seems to have happened, but we'll tap AC and we'll check the regression calculations again. Option and number 3. And here we can see again a very high correlation, a good fit, almost 0.99. But these other A and B have changed from before. And let's make the same prediction that we made before for a 240-minute walk. So 240 minutes, and we'll choose option, go down to regression and check the how far we would predict she would walk with this new model, and the prediction is much lower, only 13 kilometres, a lot less than the earlier model you remember was predicting she would walk maybe 20 kilometres. So the logarithmic model is taking into account the fact that she seems to be slowing down a bit as the walk gets longer. That's the end of our adventures for the moment with bivariate statistics. Students can use ClassWiz with their own data, and that's what they should do to study relationships between variables. You'll find Module 11 of the ClassWiz book contains further information on how ClassWiz can be used to deal with various aspects of bivariate statistics, as well as detailed explanatory text, which can be copied for students as well as teachers. The module includes some exercises to check efficient ClassWiz use, some examples of activities to suggest educationally valuable things to do, and some guidance for teachers. You can download this book freely from the Casio Worldwide Education website. Happy calculating!